This is section 9.3, solving quadratic equations using square roots. So remember, a quadratic equation is an equation that can be written in the form y equals ax squared plus bx plus c. And in this case, for the section today, it says you're going to learn how to solve quadratic equations in the form ax squared plus c equals 0 by using square roots. So ultimately, b in these equations today is a 0. So that's why you're not seeing that middle term, the linear term, as they call it. So in this, we are going to be solving the equations where y is 0 and where b is also a 0. So equations in this form. All right, so before we get into it, a little bit of a note here about the square root of x squared. If you have an equation with the square root of x squared, it actually equals the absolute value of x. We're going to see that a lot in this section. And here's the reason behind it. So I'll talk about this in a moment, but ultimately there's already been numbers plugged in for x right here. So I'll explain what I mean by this. All right, so if I have the square root of x squared, actually I'm not even going to go that far yet. I'm just going to say, let's say I had an x squared equals 4. So let's say that's my original problem. So let's call this its own little example. All right, so if the example is x squared equals 4, well, hopefully at this point you know that to undo a square, we take a square root, and we have to do the same thing to both sides of the equation. That will cancel out the square and square root. However, if I just back up for a second here, just think about this. What numbers could I plug in for x that would make this equation true? Well, obviously I could plug in a 2 because 2 squared equals 4. But there's another option. There's also a negative 2 because negative 2 times itself, which means if you square it, you multiply it by itself, negative 2 times itself equals a positive 4 because a negative times a negative is a positive. So there are two options. So in this, x could equal negative 2 or positive 2. Two options. Well, that's what this is saying. If I were to plug in a 2, a positive 2, and square it, and then take the square root, well, that's equal to the square root of 4, which equals 2. But also if I plug in a negative 2 and square it and take the square root, which is still equal to 2. So there's two possibilities here if this is your original equation. X could equal a negative 2 or a positive 2, a negative 2 or a positive 2, and you'd still get out the same value. You'd still get out a 2. So that's why we say the absolute value of x is equal to the square root of x squared, because it could take on a negative or a positive value, because if you square it, it turns back into a positive. So this is the main point to drive home on this slide. If you take the square root of a variable squared, it equals the absolute value of that variable. All right, so this one says solve by using square roots. So like I said to start this lesson, we're going to add the constant to the other side. At least I think I said it. I thought it. I hope I said it. On all of these, we're going to be adding the constant to the other side first. So in this one, we get 16 equals x squared. And now at this step, this is just like this previous example. Now we could think about it and say, okay, well, just thinking about this, I could plug in a 4 because 4 squared is 16. Or I could plug in a negative 4 because negative 4 times itself is also 16. So on this one, you can just get the answer. But I want to show the work because eventually these are going to be a little bit tougher and it's not going to be that obvious. So I'm going to show that I'm taking the square root of both sides of the equation. And as I said on that last slide, right here, maybe I should make this a different color. Right here, we've got that square root of a variable squared. Square root of x squared is equal to the absolute value of x, and that comes from that last slide I was just talking about. So on this one, the square root and square are going to cancel, but I need to write this as the absolute value of x, because again, x can take on a positive or a negative value. It's a variable. It can take on multiple values. So that equals the square root of 16. The square root of 16 is 4. And this is an equation that you would have solved in the first few weeks of school, an absolute value equation. So you have to think of what numbers could I plug in to make this true? Well, 4 or negative 4, if you take the absolute value, gives you out a positive 4. So this, we have two solutions. You'd say x equals a positive or a negative 4. And there are multiple ways to write your solutions. You can write them out in this way, but ultimately the fastest way is to use a solution set. So you just say negative 4 and 4 are your solutions. That's it. That's my answer. All right, and the next one, solve by using square roots. So on this one, there is no constant added on. It's as though as if it started with a minus 25. It's like it started out as 0 equals the quantity x minus 1 squared, minus 25, and you added that 25 over to the other side to get this. So again, we're always trying to get that quantity squared by itself. It's already by itself in this one. It's like the first step's been done for you. So on this one, we have a squared. So we're going to take the square root of both sides. Well, this is exactly the same as what I was talking about in this slide. The square root of a variable squared is the absolute value of the variable. It's just in this one, it's an expression squared. So it's like you've got a giant variable, like a y right here. It's like if you were to say let y equal x minus 1, and that's what it would become, the square root of y squared. So you'd still need to say the absolute value of y. It's still the square root of a variable squared. So without having to write all of that, I'm just going to keep that in the back of my mind. So the square root of 25 is over here. On the right-hand side, it's the square root of some quantity squared, which means I need the absolute value of that quantity, in this case, x minus 1. All right, now I take the square root of 25, which is 5. So 5 equals the absolute value of x minus 1. And then just like in the last one, I'm thinking of what makes this equation true. So again, this was something you did in the first few weeks of school, so it's been a while. But essentially, you're asking yourself, what can I plug in this place? If I were to just make this a blank, what numbers, what constant could I plug in that blank to give me out a 5 from the absolute value? Well, I can put in a positive 5, because the absolute value of positive 5 is 5, or a negative 5, because the absolute value of negative 5 is also a 5. So if it were just a blank, I'd put in a negative 5 or a positive 5. But it's not just a blank. It's an x minus 1. So what that means is, if it were a blank, I'd say that blank is equal to negative 5, or that blank is equal to positive 5. But it's not just a blank. It is an x minus 1. Another way you could look at this is if you did write this as a variable. If you were to say, let y equal x minus 1, you could put a y here. You could replace then this with a y. And then you'd say y equals negative 5, or y equals positive 5, and then you'd replace that x minus 1 back in for y. X minus 1 is negative 5, or x minus 1 is positive 5. And then you'd solve those equations. So that's two ways of looking at it. I'm going to skip the let y equals piece from now on. What I'm going to do is what I was doing originally. I'm going to take the square root of both sides, take the absolute value of the expression when it's an expression squared, and I'm taking the square root. And then I'm going to just say this expression inside the absolute value can either equal the positive or the negative of this constant. So x minus 1 can equal negative 5, or x minus 1 can equal positive 5. Solve these equations, add one to the other side, you get negative 4, or add one to the other side, make sure that looks like a minus 1, and we get 6. And again, just to write your answers, just use set notation and put them in numerical order, and that way I know that those are your answers. Nice and simple. All right, so just to recap, again, get the constant to the other side, take the square root, because it's a square root of a quantity squared, we need the absolute value. Take the absolute value, and then, take the quantity inside the absolute value and set it equal to the negative or the positive of this constant. And then you solve those to get your answer. That's going to be the process on every single one of these. So here, it's like there's a plus 0 out here, so there's nothing to do. You can't subtract that off or add it to the other side. It's not going to do anything. So on this one, we can take the square root right away. So I've got the square root of 0 equals the absolute value of x plus 7. Well, the square root of 0 is just 0, and that equals the absolute value of x plus 7. So on this one, if you are to say x plus 7 equals negative 0 or x plus 7 equals positive 0, well, negative 0 and positive 0 are the exact same thing. These are both equal to 0. So this is the same exact equation. So on this one, we don't need to create two equations. We only have to create the one equation, x plus 7 equals 0. Subtract 7 from both sides, you get x equals negative 7. And again, if you want to use set notation to show that that is your answer, that's good. That's it. You could always double check your answers as well. If you want to plug negative 7 back into the original equation, is negative 7 plus 7, which is 0, Is 0 squared 0? Yep, so it's good. On the last one, if I plug in negative 4 minus 1 is negative 5. Negative 5 quantity squared is 25. If I plug in 6, 6 minus 1 is 5, and 5 squared is also 25. So both of those are good. And on the first one, if I plug in negative 4 and square it, the quantity squared is 16. Minus 16 is 0. And positive 4 squared is 16. Minus 16 is also 0. So to check your answers, just plug them back in. If you don't get a true statement, you know you made some error in your work. All right, so let's just see what we have left to go here. I think it's just these two. Yep, two more to go. So on this one, we've got a leading coefficient. So what I'm going to do first is divide off the leading coefficient. So divide both sides by 4. I'm just trying to get that quantity squared by itself so I can take the square root nice and easy. So divide off the 4, those are gone. I have the quantity x minus 3 squared equals 9/4. And I'm going to leave 9/4 as 9/4 because ultimately I'm going to take a square root of both sides, and both 9 and 4 are perfect squares, so that's a little bit nicer than trying to simplify and then take a square root. So in this one, I get the absolute value of x minus 3 is equal to the square root of 9 is 3, and the square root of 4 is 2. Oops, there we go. All right, so the absolute value of x minus 3 equals 3 halves. That means x minus 3 equals a negative 3 halves, or x minus 3 equals positive 3 halves. My two possible cases. I just have to add 3 halves to both sides. I have to add 3 to both sides of these equations, and I will get my solutions. So this is just negative 1.5. So add 3 to negative 1.5, and you get out 1.5. Add 3 to 1.5, and you get out 4.5. Just to double check, I think I said add 3 to negative 1.5. If I didn't, that's what I meant. All right, so here are my answers, 1.5 and 4.5. So those are the values of x that make the equation true. Again, you can double check. This one's a little bit worse because you've got fractions, but nope, I put 4. There we go, 1.5 and 4.5. So if you plug in 1.5 minus 3 is negative 1.5. Negative 1.5 squared. Negative 1.5 squared is 2.25 times 4. Yep, that's 9. Plug in 4.5 minus 3 is 1.5 squared times 4, also 9. So these two check out. I know that the work is correct. All right, example number 5. Solve this without graphing. The reason it says this is because in the previous section it's solving quadratic equations with graphing. That's a section that I'm skipping over for now. We might come back to it later on if we have time. But right now it's looking like we're running a little low on time. So I'm just trying to cover the ones that you will use a lot in Algebra 2. We will cover the other material in geometry if we don't get to it. So solve this equation without graphing. Okay, so if it's a quadratic equation where you have ax squared plus bx plus c, so it's not just ax squared plus c equals 0. What we're going to have to do, if it says solve without graphing, it's going to have to be factorable. Now, there are other ways around this that you're going to learn in different sections, but for right now, all we know is that we have to be able to take the square root of both sides. So how do we do that? If I were to subtract off the 9, so using previous knowledge, you might have said, okay, well, let's just get this side equal to 0, and then we would have minus 5 equals 0, and then we could try to use the zero product property after we factor this. So if we try to factor this left-hand side, and then we can use the zero product property where you set each one of your factors equal to 0. Let's see what happens. So if I try to factor, to get these to multiply to a negative 5, and that would be positive 5 and negative 1. So we have x squared minus 1x plus 5x minus 5. That gives me that trinomial. I could set each one of those equal to 0. So x plus 5 equals 0, or x minus 1 equals 0. That's a zero product property. If you multiply two factors together and get out a 0, at least one of those two factors must equal 0. Subtract 5, you get x equals negative 5, or add 1 to both sides and you get x equals 1. So the two solutions, negative 5 or 1. So that's using prior knowledge. So how does this tie into this section? Well, that's one way of doing this problem. The second way, because that might not always work, and the second way here, let me show you. So let's call that way number 1, and then way number 2. So it's another tool in your toolbox in order to solve an equation like this. So another option, if you just look at this left-hand side, you can actually factor this right away, and it's still going to equal 9. But here's what it's going to factor into. It's going to factor into x plus 2 times x plus 2. So that would give me x squared plus 2x is 4x plus 4. And that's actually the quantity x plus 2 squared equals 9. And that's how it ties into this section, because now we can solve this using square roots. We can take the square root of both sides. That's the absolute value of x plus 2 equals, the square root of 9 is 3. So now we'd set this x plus 2 equal to negative 3, or x plus 2 equals positive 3. And we solve both of those equations by subtracting out 2 from each side. So x equals negative 5, or x equals 1. So either way, we would get our solutions negative 5, 1. Now, just to be perfectly clear here, this way, the second way over here, is only going to work if you have the same thing times itself. So notice it's not equal to 0, so we can't set them equal to 0 and solve using this method. So it's only if it's the same thing times itself, because then you can write it as the quantity squared. So just keep that in mind. If you are going to try to use the second method, you have to be able to get the same quantity times itself to write it as that quantity squared, and that way you can solve using square roots. Okay, so your homework here is 9.3 practice B. That's a worksheet. I will go through half of that worksheet with you. So I am going to do the even problems with you, and then you are responsible to finish the worksheet, but of course you are supposed to take notes on the even problems as I do them. So here we go. Number 2, the first thing here is that it's already a variable squared by itself, so I can go ahead and take the square root. Now what's going to happen on this one, because it's negative 15, think of, so before I even take the square root, I suppose I can just stop here and say, hang on a second. Think of a number that you can plug in and square and get out a negative. So a negative times a negative is a positive. A positive times a positive is a positive. So there's nothing in the real number system that you can plug in to square and get out a negative 15. So because there is nothing in the real number system that will allow you to square it and get out a negative 15, we say there are no real solutions. No real solutions. Another way you could have looked at this is if you did take the square root of both sides and said that this implies that the absolute value of x is equal to negative, the square root of negative 15. Well, again, right here, you're trying to take a square root of a negative, so there's no real solutions. All right, so that's my answer for this one. There are actually what are called imaginary solutions, or potentially imaginary solutions, but that's something we're going to talk about in Algebra 2. All right, going on to the next one. So anyway, that's why I say no real solutions. Number 4, on this one, subtract 9 from both sides. We get x squared equals negative 9. And again, is there anything in the real number system that you can plug in for x, square it, and get out a negative? And the answer is no. So again, I'm going to say no real solutions. So you can see why I picked the evens, because we hadn't run into that in the notes yet, but I wanted to cover it with the worksheet. All right, in number 6, this one is finally a little bit different. We will have some solutions here. If I subtract 10 from both sides, I get negative 2x squared equals 10 minus 10 is 0. Divide both sides by negative 2, trying to get that quantity squared by itself. I get x squared equals 0 divided by any number is 0. Square root both sides. The absolute value of x equals, the square root of 0 is 0. So what can I plug in to get out a 0? Well, the absolute value of any number other than 0 is not going to be 0. So the only thing I can plug in is 0. So x equals 0. That's my only solution. So I'm going to show that with my set notation, that my only solution is 0. Going on to number 8, subtract the 7 from both sides. I get 9x squared equals 8 minus 7 is 1. Divide both sides by 9. I get x squared equals 1/9. And that's nice because both of those are perfect squares. So I'm going to square root both sides. The square root of a quantity squared is the absolute value of that quantity. The square root of 1 is 1. The square root of 9 is 3. So in this one, what two numbers could I plug in to get out a positive 1/3? Well, I could plug in a negative 1/3 because the absolute value of that is 1/3, or a positive 1/3 because the absolute value of positive 1/3 is also 1/3. So my two solutions here are negative 1/3 or positive 1/3. All right, number 10. On this one, it's the quantity squared by itself right away, so I'm going to take the square root to start. Get the absolute value of x plus 5 equals the square root of 49 is 7. To solve this, I'd say x plus 5 equals negative 7, or x plus 5 equals positive 7. Subtract 5 from both sides, you get negative 12. Subtract 5 from both sides on this one, you get out a 2. So negative 12 or 2 are my solutions. And the last one here, number 12. I need to get that quantity squared by itself first, so I'm going to divide both sides by 25. Again, kind of nice because 49 and 25 are both perfect squares. So I'm not going to simplify that yet. I've got the quantity x minus 1 squared equals 49 25ths. To undo the square, I'll take the square root of both sides. The square root of a quantity squared is the absolute value of that quantity. The square root of 49 is 7, and the square root of 25 is 5. So to solve this, I am going to set x minus 1 equal to the negative or the positive value of 7/5. And 7/5 is 1 2/5. So I'm going to write that as 1 2/5, negative 1 2/5. Or, make that a little better. Or x minus 1 equals positive 1 what did I say, 2/5? Not 1/5, but 2/5. So add 1 to both sides here, and I get x equals negative 2/5. Add 1 to both sides here, and I get x equals 2 2/5. So my two solutions, negative 2/5 or 2 2/5. And there we go. All right, moving on. Let's see, describe and correct the error and solving the equation. So you need to find the error here. I'm going to tell you it's something in these last two steps. Number 14, it says a can of juice has a height of 10 inches and a volume of 160 pi cubic inches. The volume of a can with radius r is given by this formula. Write an equation describing the situation where r is the radius of the can. All right. So writing an equation describing this situation, so using these numbers, the height of 10, the volume of 160 pi cubic inches. So you just need to plug in numbers. So the volume, it says 100 is 160 pi, so plug that in for v. So 160 pi in place of v equals pi r squared times h. It says the height is 10, so we're going to plug in 10 for h. Okay, so write an equation. It's an equation because it has an equal sign describing this situation. Done. R is the radius. Okay, find the radius. So now it essentially means solve for r. So 160 pi equals pi times r squared times 10. I'm going to divide both sides by 10 pi. That's going to cancel out pi here, but also here. And then it's going to cancel out the 10s, which is going to make this a 16. So I get 16 equals r squared. Well, to undo that squared, I need to take a square root of both sides. That's going to give me 4 equals the absolute value of r. So my two answers here are going to be negative 4 or 4. However, We're talking about a radius of a can. You can't have a negative radius. You can't have negative 4 inches as a radius of a can. So that is an extraneous solution. It does not make sense in the context of the problem. So the only solution here is 4, and we're dealing with inches, so that's 4 inches. So the radius of the can, the radius of the can is 4 inches. And again, this one does not make sense. This is called an extraneous solution. Extraneous solution. And you don't have to necessarily write this. I'm just writing it so you understand what I'm saying. Extraneous solution does not make sense in the context of our problem. All right, so let's see. For 15, you need to solve each equation without graphing. So this is very similar to what I was doing in the last example of the notes. Again, I challenge you to try to factor this left-hand side first and see if you get a quantity squared. Okay, do that on both of these. So on this one, see if you get a quantity squared equals 49. So just factor the left-hand side, see what you get, factor this left-hand side, see what you get, and then try to solve this using square roots. If you don't get a quantity squared when you factor this, then you might need to subtract 25 from both sides and then try to factor the trinomial and then use the zero product property. But again, try to do this on both of these problems. All right, if you have questions, let me know.